Thanks.
Technology.
Mm.
Okay. Okay. Thanks, Joe. All right. So I'll just put share my screen with the notes, which I hope you've all received. So okay, I sent them out last week as usual. As I said in that email last week, we've got 3 sessions, and then I'll be away for about 6 weeks, and then we'll start again after that. So I'll let you know what the future sessions are going to be. We've got quite a few ideas. We just have to put that together and decide how to go ahead. But for the next 2 weeks after today, it's all organised, and then we'll have a break for a while. So today we're going to talk some more about the project engineering process. Okay, we have touched on this briefly, but it's worth going into a bit more detail because this is really important, particularly when you get into bigger projects, which you all will at some point, if you're not now. It's about teams and working together as a team, and working in a systematic manner so that everything gets done that needs to be done, and being aware of time schedules, which are really important. One thing that I'll mention before we start is that if you are working on a large project in a team, and you've got a team of engineers and other people, draftsmen and project managers and so on involved, but particularly in the engineering team, if I've just got something in mind that I wanted to share with you, because something that I've never forgotten. We worked on a very large hospital project in Queensland, and I was leading that team. We had a team of up to 10 engineers working on the project at any one time. And we used to have weekly meetings. We had a big spreadsheet of all the things that had to be done and who was responsible and so on. And I can see clearly that one day, one of the guys in the team had a very tight time schedule to get a particular task completed, and he was really struggling, and I could see it. And but everybody else was busy as well. And one of the guys in the team put his hand up and said, "I'll help you. My work can wait till next week. I'm not critical this week. I'll give you a week's work and help you get it done." And they got it done. And I was very proud of that. So that's what teamwork's about, is understanding what your colleagues are doing, as well as yourself, obviously, but and helping out if you can, and helping each other get things done. That's what it's about. It's about working in a team. So let's get cracking. So just going through the notes, the HVAC design and construction process involves many steps to create an efficient and effective system for providing cooling, heating, and ventilation in a building. The most common key steps and activities we'll talk about this morning. And as you know, every project is unique, and the equipment and systems, as well as the personnel, will vary for each project. So obviously the equipment's going to be different. You'll come across new systems each time you do a project. Technology is advancing. Energy efficiency is driving equipment design. So all these things keep changing. And the people you work with, I mean, in your own teams, you work with the same people most of the time. But your clients, the architects, everybody else, every project there'll be a different set of people. So you've got to start again with different people. That's about working with them and getting the job done. Everything we do is part of a process that we need to follow to achieve a successful outcome. Following the process as closely as we can enables the work to be carried out in the most efficient manner, and will help to ensure that time, costs, and quality objectives are achieved. These are important things: time, cost, and quality. It's always going to drive what we're doing. One thing that is really important to develop as one of your skills is understanding the timing of a project and achieving those times. and making sure that you know what all the timeframes are and you've got a plan to get there. We've got another one joining us now. So just morning, Kaushik.
Good morning, Peter.
How are you? We haven't seen you for a while.
I was
Welcome
busy last month, so I couldn't attend
Yeah.
the sessions. I always keep reading the notes.
Oh, yeah.
It's
Oh,
on my
okay,
note.
good. Oh, well, good that you could come back and say hello again and join in. Thanks for that.
Yeah.
So we've made a start. We haven't gone very far, so we'll just keep going. So the 4 big C's I've put in here: communication, collaboration, coordination, cooperation with internal and external stakeholders is a fundamental requirement throughout the project. So communication is vital. You know, you've got to talk to people, whether it be face to face, on the phone, by email. Keep in contact, let them know what's going on, and make sure you get to know what you need to know to get the project done. So if you start a new project, but you're still involved in a current project, this is a common thing. There'll be conflicting priorities to be managed. It's common and normal for this situation to occur, but can be very challenging. In this case, following the processes that we're going to talk about will assist in ensuring that all the work is carried out systematically and on time. So it's just bear with me, because I'm going to sort of go over similar things a few times, because I just want it to sink in a bit that these things are important. It's important that all staff involved in a project are able to do their work in a supportive team environment. If you feel that you can't manage the workload, you've got too much on your plate, it's starting to stress you out, then you request assistance from your management. Now, this is a natural thing to do, but some people don't like to do that. They think, oh, well, I've been given this job, I've got to do it. But we're a team. We ask for help if we need it, okay? Don't take on too much if you can't manage it. The important thing is to get the job done on time, to the right quality, and within your budget. So if you need help, ask for it. Regular team meetings help to identify potential hurdles and develop strategies to keep on track. Excuse me. By forming strong and supportive relationships with your team, the workload can be managed, and you can enjoy the process. So this is part of why we work. We want to get some enjoyment out of it, don't we? You don't want to you want to wake up in the morning and think, oh, great, I'm going to work today. It's going to be fun because we're working on this project and, we're going to get this done. You don't want to wake up and think, oh, I don't want to work today. It's all too hard. It's about making your work environment enjoyable and looking after your mental health. I know it's a bit overused term at the moment, but it's important that stay healthy and enjoy your work. Now, I've just thrown in something that I came across reading a book recently. There's a word in the Chinese language that means both crisis and opportunity. So if you're in a crisis situation where an issue seems too hard to resolve, it's quite possibly an opportunity to look at the issue differently and find a better solution. Now, this happens time and again. You get to a point where you think, oh, I can't resolve this, but talk to people about it. There could be another way of doing it, and there usually is. And I've thrown in this little gem as well, the 7 Ps. Proper project planning and preparation prevents poor performance. So I don't know whether you've seen that before. There's a few more Ps that could be put in there, but they're a bit rude, so I won't put them in. So that's a good thing to remember, the 7 Ps. There's actually a building company called the 7 Ps, and this is what they go by. Okay, so this was going to be A to Z, but I didn't get to Z, but we'll start with A. So now, for the guys in the contracting field, this is more aligned with what what you do. Consultants do things a little bit differently, but I think it's still relevant, and also gives you an understanding of what the contracting side of the business is up to. So the first step is to estimate and secure the project. This is the initial stage of becoming involved in the project. Project documents are provided usually electronically now to enable our estimating or sales team to evaluate the scope of work and price the work accordingly. This can take, one day or even a few months, depending on the size and complexity of the project. The hospital project I mentioned earlier, the estimating phase for that project went for about 6 months. So it was a very large project, but what tends to happen in projects like that is you'll end up pricing it half a dozen times, because you put your first price in and then they'll want to change something, you price it again, they'll change it again, they'll price it again, and so on. It's a bit frustrating, but you've got to stick with it to eventually win the project. So we won the project. The estimating or sales team, excuse me, estimating team then hand over the project to the design and construction team for execution. So the steps outlined here are a minimum. There could be others, there mightn't be as many. These will need to be carried out. As I said, every project is unique. The following steps are a guide to what to expect, but the scope will vary from one project to the next. I've highlighted a paragraph here. Note that in every stage of the project delivery, timing of the various activities is crucial. So I'm going to say this again and again. Timing. One skill that I think every engineer needs to develop is a sense of time. When do I have to have this done? What do I have to do to get there? A thorough understanding of and compliance with the project timeline and milestones is essential. If the milestones aren't achieved, there may be serious consequences, such as financial penalties. So at the end of the day, well, in a construction project, these penalties will occur at the end of the project if you don't finish on time. But even during the design phase, if you're not achieving targets, you may be penalised. So these are the steps that normally occur in the project handover meetings. So you receive the project documents, which might consist of a design brief, criteria, scope of work, specification, drawings, and so on. Receive and discuss the project design and construction program. I've got a sample of that I can show you. I don't know whether you've seen anything like this. This is actually a design part of the program. So there's broken up into different sections: strategic definition, preparation and brief, concept design, develop design, technical design, and so on. And then it goes into construction later on. This is just a bar chart, which shows you the start and stop times of the various activities. So the red bar is the time allocated for this activity. And then the activities within that heading are shown in the green and yellow bars. So you're working your way down, and from these programs, they develop a critical path to determine what are the most critical things that need to be done in what order. So I'm sure you've heard of critical paths. That will be something that you'll come across again and again. And if your work is on the critical path, the spotlight is on you to achieve the times that are required. So, sorry, something's gone. Oh, okay. So something went wrong with my computer there for a moment. All right. So next, we want to identify critical parts of the work, such as, or need to discuss this at the handover meeting. We need to get all the information about the project. The estimating team, you can imagine on a project like a big hospital they've been working on it for 6 months just to win the job. Okay, so they've developed a lot of knowledge about the project over this time. And as an engineering, as a project group coming into the project, you don't know anything about that unless you've had some involvement with estimators during the project or during the estimating phase. You don't know what's been discussed. And at this handover meeting, all that information has to be downloaded to the team so you can get on with it. So one thing is that the estimating team will understand is what are the critical parts of the work, such as long lead times. And if you've got chillers in the project, and if they, depending on the stage of construction, you might, and you normally do start a project when it's a bit too late. So suddenly there's a big rush to get everything ordered and delivered in time. And chillers are quite often the most important thing because their lead times may be 20 weeks. If they're very big chillers, they might be 6 months. They better come from overseas. And depending on the construction program, you might need to order those immediately. So that could be the first thing you have to do. Put everything aside and work on the chillers. You'll talk about potential risks and strategies for mitigation of the risks, such as design performance criteria, design responsibilities, acoustic criteria. You may discuss opportunities for improvements and cost savings in the project work. As you work through the project, more opportunities may come to light, and they probably will, and you can deal with those as they come up. Discuss any items not included in the scope of work. So there might be some things that have come into the project during estimating that aren't actually documented in the scope of work. So you need to be aware of these. And you'll discuss the project budget and the target profit margin. Again, that's very important. What are we trying to achieve? And what's the profit margin going to be? So setting up the project. Firstly, you may not have to do this yourself, but the filing system for the project needs to be set up. Now, this is very important throughout the project to file everything correctly. I've worked on large projects where some engineers have found their own way to file things and haven't followed the system, and then they happen to leave, and then when you try to find things, it's very difficult. So, you know, find out what the correct filing system is for the project and use it. Now, arrange access to any project management software applicable to the project. For example, Aconex. I don't know whether you've used Aconex yet, any of you guys, but that's a popular project management software tool that's used in a lot of construction projects. Produce a procurement schedule. Now, this may not apply to your small projects. I'm talking about, this is a process of what you would do. Some of the things you scratch this out and say, well, that doesn't apply to this project because I'm only, on this project, we've only got a few fans and a few air conditioning units. So you don't need it. But on a larger project, you'll need something like this. You'll need to list all the equipment and work out when you need to have it approved and ordered and delivered to site. So I've got a procurement schedule, which is, I'll show you. It's a bit hard to read. I tried to download something off the internet, and there's lots of stuff there. If you wanted to Google procurement schedule, you'll find all sorts of things. But the companies you're working for should have their own procurement schedules, a standard form for filling in, and generally the idea with a procurement schedule is to talk to the site people. When do you need this to be on site? And again, reference to the construction program. Okay, we need it, let's say we need it in 6 months. All right, so then you can work back to, well, when do I need to do my work to ensure that we can go through all the approvals and all the manufacture and have it delivered to the site within 6 months. Okay, so that's, you've got to put the binoculars on and be looking ahead all the time to say, when do we need this? When do I have to start my work on that? So the other thing that will need to be done is the drafting program. Determine when the engineering, so from the engineering point of view, we need to determine when the engineering must be completed to enable drafting to proceed to meet the construction program. So normally in a contracting organisation, the drafting team, so the drafting manager or the senior draftsman for this particular project, will produce a drafting program. And that will be based on the construction program. And it will have, they'll make a list of all the drawings that they intend to produce. And when those drawings need to be completed so that manufacture of ductwork mainly can proceed. Okay. And from the engineering point of view, you know, we've got checks to do before the drawings can be produced or finalised, and interaction with the drafting team. So we need to be aware of when they need to produce their drawings so that we can do our work and help them to get their work done. Determine the priorities for engineering activities based on the procurement schedule and the drafting program. Assign resources to carry out the work. So this is if you're leading a team, you need to determine how many people do you need to work on this project to get it done. So in these programs, excuse me, all these programs, the construction program, the drafting program, the procurement schedule, they're all live documents and they're likely to change. As the project proceeds, there might be delays. You have to change your programs to suit those delays. Sometimes delays are your friend because it gives you time to catch up. And there is a project I worked on, a long time ago, 40 years ago nearly. A huge project. Yeah, it was funny actually. When we got involved in the project, we were way too late to be on site. And so we were behind the 8 ball to start off with, and didn't know how we were going to catch up to the builder. But I won't say where it was, but you might guess. But the local electricity authority, the unions decided to go on strike. And so there was no power to this part of the world for 2 weeks, believe it or not. And so we had no power on site. We were working on site, in site sheds. So we went out and bought a generator and we powered our own site office with a generator. And we had 2 weeks where nobody asked any questions. There was nothing happening on site. And we actually caught up with the builder in those 2 weeks. So we were very lucky. So that's an example of things that can happen. You can't rely on that. But programs do change. And sometimes it works in your favour and sometimes it doesn't. You need to determine and agree on the types of HVAC systems to be used in the project if it's not already given to you. And then finally, with all this information, you can prepare an engineering program based on the project program, procurement schedule and drafting program. Now, this is an ideal world for you to produce an engineering program, but it's a good thing to do, even if it's just a simple thing. But on a big project, it becomes very complex and you need to be able to understand what your priorities are and when you have to achieve them. Once again, identify and engage any additional resources required to achieve the project program targets. And this is an ongoing thing too. As a project evolves and some activities become critical, they get on the critical path of the program, you might need to get some help to get the things done. So don't be afraid to put your hand up and ask if you need it. Again, so we're going to the design phase. This is from a mechanical contractor's point of view again, but it's relevant to the consultants. Engineering activities in the two most common project types are listed below. So that's design and construct or construct only, which is pretty much most of what we do, one or the other. And quite often more D&C projects these days. The activities are listed in approximate order of execution, but unfortunately, the order of execution doesn't always follow the ideal plan. So you've got to be a bit flexible and be prepared to accept changes. Activities are carried out in order of priority to ensure that the project construction program is met. Sometimes priorities will change, so the engineer needs to adapt activities to suit any changes. So again, I've mentioned collaboration and coordination with the various stakeholders, architects, other engineers, contractors, to achieve an HVAC system design that meets the building and stakeholders' requirements, as well as complying with all the relevant codes that we've been talking about. NCC, Australian standards, building permits. On a D&C project, you'll have to look at the building permit and even the development consent to see what conditions the local authorities have put on that project. They might say in the mechanical services or ventilation systems, you must do something. So just be aware of those things. Regular meetings are held in-house to resolve design issues and to ensure that all activities are being carried out in accordance with the program. So in the contractor's arena, these meetings, project meetings will be held, or project team meetings will be held, managed by the project manager. But as I said before, on the hospital project, we used to run separate engineering meetings, just the engineers working on the project, so we could work together and keep up with all our targets. The list of activities shown below, or we're going to talk about today, is not intended to cover everything, but provides some guidance on a typical engineering process. Now, again, this could be a large project, but so you can strike out things that aren't applicable, but some of them will always be applicable to your projects. We've got a more comprehensive list of activities for design and construction phases in our project design checklist, which should be referred to and signed off for all projects. Now, again, that's an ideal thing, but it's a good guide. I'll show you. This is an engineering design checklist. It's just got a list of things that need to be considered, and there is space there to sign it off. So in a quality assurance system, something like this, you may need to complete these forms to say that you've done all these things, or they're not applicable to the project. So you can see there's general things, guarantees that we've had to make for the project, looking at the chillers, looking at the cooling towers, looking at pumps, pipe work, air handling units, fans, ductwork, attenuators, etc., etc. So that's a more detailed list of things to do. But again, there might be things in a project that aren't mentioned in the schedule. So it's just a guide. Now, it helps to set daily and weekly goals to keep focused on what you're trying to achieve. So now our guys have a daily meeting to talk about what do we need to achieve today, or what do we need to achieve this week. And looking at a program, you might look further ahead and say, well, what do we need to achieve in the next 2 weeks or 4 weeks? It's quite common for builders to have they have their overall construction program, which goes from the start to the finish of the project, which can change, but the initial project, but then they'll start to break it out into 2 weekly focus programs, for instance. So they'll get everyone together and say, look, in the next 2 weeks, we've got to achieve this. So everyone has to have their contribution to how you're going to achieve that in the next 2 weeks. So firstly, I'll talk about the engineering design phase in a design and construct or D&C project. Once again, the first comment I'm making there is ensure that all steps carried out in this process are thoroughly documented and filed in the correct location. This is really important. It's probably a little bit easier these days using computers, but back in the dark old days when I started work, and it's not that long ago, it was in the 90s when we started to use computers on projects, but prior to that, everything was in paper. And if you didn't file it in the right spot, you wouldn't have a clue what went on before you got involved. It's the same with computers. If it's not filed in the right location, someone else comes along later to find a particular thing that they need to find out, and it's not in the right spot, just can't find it. Determine which areas require air conditioning and or ventilation. So you need to gather all the information about the project. Now this is going a bit broader now. If you haven't been given this information, you need to go and collect it. If we've just been given a job and so we want you to design an HVAC system for a project, we need to find out what's the building used for. In other words, get all the architectural drawings. What specific requirements or constraints do they have? Then review all the drawings, visit the site, perhaps, and communicate with the stakeholders to understand the project's goals and objectives. Agree with the stakeholders what the design criteria for the project will be. Very important. What are you trying to achieve? What temperatures are you trying to achieve? What humidities do you want? What airflow rates? All those things need to go in. Be agreed. Determine the thermal zoning to be adopted for the project. So these are things that we've talked about previously. Review the relevant parts of the NCC and applicable Australian standards. See what applies to this project. Prepare a schedule of air-conditioned and ventilated areas, so you know that becomes a guide as to what you're going to do in the project. Prepare a schedule of smoke hazard management requirements, if applicable. So from the NCC, the type of project, the building classification, the size, the height of the building, all those things that we've talked about, and work out what smoke hazard management applies to if any, to the project. There mightn't be any requirements. At this point, you can issue requests for information or RFIs. Now, this applies to whether it's contracting or consulting. If you need more information, you need to ask for it, and usually an RFI is the form you use. So when doing design, you might need some glazing performance data. This is probably the first thing you'll find that nobody seems to know what glass they're using. If it's designed by a consultant, they've designed for a certain glass performance data, U value and shading coefficient, but that might change. Somebody might have a great idea to change the glass because they can save $1 million. But what effect does that have on the design? It has a huge effect. So you need to get that confirmed. What building materials are being used? The architectural drawings may not be clear on what is being built from, and clarify any design brief criteria, any missing documents. Sometimes there's reference to a document that you haven't got, so you need to get it. You can carry out the cooling and heating load calculations to determine the capacity of the HVAC systems required to maintain the required indoor conditions. You can carry out ventilation system calculations for supply and exhaust, obviously with reference to IS 1668 or whatever applies to the project. The ventilation might be stipulated in the design criteria. Well, it will be, it should be. But if it doesn't comply with IS 1668, well, you have to comply with 1668. Based on the results of the heat loads and ventilation calcs, you can prepare preliminary schedules of all the HVAC equipment. If you've got chilled and heating water systems, the schedules will obviously include chillers, boilers, cooling towers, pumps, etc. Identify any potential value engineering opportunities and discuss with the engineering manager or your supervisor for the project or your colleagues, your project manager, regarding which options you should include in the project. So, you know, there may be things that come to mind as you're looking at the documents and think, well, we could do something a bit differently here. And if everyone's in agreement to that, well, it's worth pursuing. If it's a benefit to the time of the project or the cost of the project or the quality. Again, if there's any long lead time equipment, prioritize these and seek urgent approval. So if you've got chillers, air handling units sometimes have a long lead time. Most air handling units these days are made overseas. There are still some manufacturers in Australia, but unfortunately the pricing is quite high. So they tend to come from overseas and they can be 12 to 16 weeks delivery, depending on the complexity of the air handling unit. So be aware of those things. Then you can prepare design layouts and schematic diagrams for the air systems, showing air outlets and ductwork design for the HVAC systems. Consider factors such as the NCC requirements, air velocities, pressure losses, etc. We've talked about all that. Noise and space constraints. Indicate insulation details in accordance with the NCC and acoustic design requirements. So all this information you need to get marked up to give to the drafting team so that they can continue with their work. And the same goes for water systems. If you have them, mark up some drawings and look at all those factors, the design factors. Consider thermal expansion and contraction, and indicate the insulation requirements. If necessary, well, in a design project, you will have to provide design certification to the local authorities. It may not apply, but usually it does. You can carry out fan static calculations, and then you can update the equipment schedules with the calculated static pressures so that you're now ready to get firm pricing on that equipment. Once you've completed your static calcs, you know what the flow rates are, you know what sort of fan you need, you can get the schedule updated with the correct data. And this is a gem that I'll mention again and again. Always consider and resolve any potential acoustic issues during the design phase. Don't overlook it, because it'll come back and bite you. If you have an acoustic issue later on, if you've got a noisy fan or noisy air conditioning unit, you know, it's hard to resolve acoustic issues after everything's built and it's being commissioned and oops, suddenly we've got a problem. Try and be aware of the acoustic issues up front and get them resolved before it gets built. If you've got water systems, you'll need to prepare a control valve schedule to give to the controls supplier or subcontractor so that they can carry on with their work and select the control valves for the project. And once they've selected their valves, they'll send it back to you to approve it, and it can be procured for the project. Carry out pump operating pressure calculations if you've got pumps, and update equipment schedules again. So similar to fan statics, you do your pump calcs and then update the schedules. Then get some quotes, select. You can select the equipment yourself or obtain quotes. You're going to have to obtain quotes anyway for the equipment from the suppliers. And then again, update the equipment schedules and issue for approval. So when you get the quotations back from the suppliers, it'll have a lot more technical data on it. You can put all that data into the schedule and get it in for approval, so you can get it approved and underway. It's good to prepare a description of the controls of the system. So again, remember, we're in the design and construct phase here. So we're driving the design. We need to drive the way the systems are going to be controlled. So you need to prepare a description of the control, which will then go on to the controls subcontractor again. And it helps, if you've got a BMS system, do a points list, all the points that need to be controlled and how they're controlled. They digital outputs, digital inputs, etc. And when the equipment is approved, update the schedules for construction. So now we're assuming we're going to a construction phase after this. When we update a schedule for construction, that means that can be issued to the suppliers as the final schedule for them to manufacture or deliver the equipment as required. And this is done progressively in accordance with the project program. So you're not going to try and do all this up front. Depending on the program, you select your priorities. Let's say you've got to get the air handling units sorted out first. But it mightn't be for every floor. It might be just be for one floor or one part of the project. So get those done, get them in, get them approved, get them on the way for manufacture. Then look at the next priority. Do we need to get more air handling units? Do we need to get fans? Do we need to get pumps? Work out what you need for specific parts of the project and to suit the project program. I'm going over things, but I'm just trying to get it into your heads that keep thinking about time and priorities. Another good thing to do, you don't have to do this, but if you can fit this into your schedule of work, progressively obtain and file data for the operation and maintenance manuals. Now, you don't have to produce these until the end of the project, but if a project runs for a long time, let's say it's 12 months, by the time the 12 months is up, the suppliers have moved on. They've moved on to many other projects and they've forgotten about your project. They don't care about it, really. So if you can get that data, when you place the order for the equipment, say that part of the order is that you supply us with all the data we need for the maintenance manuals. And then you can file that away and keep it so that you're not chasing it up later. If you've got time at this stage, or if you can get someone to help you work on it, it's worth writing the system description. Now, this again for the O&M manual. Part of the O&M manual is that we need to write the system descriptions. So if you can do it at this stage, I find that it gives you a much better understanding of what the project involves. And it also helps you to identify some things that might be missing. Any questions? Still awake? Sorry, it's a bit laborious, but maybe this is something you can keep. You know, if you're working on a project, just have a look at this and see what steps you should be taking. But it'll become second nature to you as you go on, that you'll find that programs drive everything. Okay, so you've got to be aware of the timing. So just comparing that to a design phase for a construct-only project. So this is where the contractor has tendered a project designed by usually a consultant or another designer. We don't have design responsibility, but we still need to do some checks to make sure that we're happy to install the project as it's been designed, because sometimes there might be some errors or things left out that need to be done. So the first thing I've said again is always ensure that everything's filed correctly, thoroughly documented and filed in the correct location. Go through the drawings and specification and highlight any items requiring clarification or any errors that you think have been made, omissions, discrepancies between documents. Sometimes you look at the drawings and then look at the spec. A good example is, say, a fan. You look at a fan on the drawing and it adds up to 500 litres a second. You look in the spec says 1,000 litres a second. Okay, there's a discrepancy between the documents. You need to note that down, make a list of any of those discrepancies and issue an RFI to get them clarified. It's worth doing a quick check of the areas that are air conditioned on a watts per square metre and litres per second per square metre basis, and just see if there's any potential issues. So, for instance, in the extreme, you have a look at an area which is, say, an office area, and it works out at 250 watts a square metre. You think, well, that doesn't seem right, because it's normally not that high. If it's just a normal office with, one person per 10 square metres or something like that, it would normally be less than 150, say. So if it's 250, there might be something wrong. Someone's made a mistake. And these checks, I mean, we're not doing heat loads, but it's good to do this and get it clarified. Just to give you an idea of the things, the procedure that I haven't actually, well, I have written it down there. I said review drawings and specification, but it's a good thing to have a look through the specification before you start. And as you gain experience, you'll know what to look for. You won't read every word in the spec, because that'll take you hours and hours, and you won't achieve much by doing it. But you'll get to learn the things to look for. So, for instance, if you're looking at air handling units, what do they ask for in the air handling units? Sometimes you'll find, and this is with all respect to our colleagues, that they'll ask for things that actually aren't available. And so that needs to be clarified. Okay, they'll say they want A, B, C, D, E, F, G. Well, you can have A, B, and C, but you can't have the rest, because nobody makes that. So it's, you need to identify those things and get it clarified. Electrical and control systems design, have a look at that and see if that makes sense. And if not, or if you're not sure, ask for clarification. There should be a fire mode design in the specification. Again, have a look at that and see if it needs to be clarified in any way. So at this point, again, request for information. Issue RFIs, make a list of all the things that need to be sorted out and get them in. And this is important to get these clarified quickly, because it's going to hold you up. So once you issue RFIs, this is one of the first things you should do, is get the RFIs in the system. You won't get an answer today or tomorrow. It might be 2 weeks before you get an answer. So you've got to factor that into your timing, that you need to go on to something else, because while you're waiting for the answers to come back, time's ticking away and you could be doing something else. But what I've said here is what we used to do quite often is request a meeting with the designer, normally a consultant, and you may know them, you may not. You may have worked on other projects with them, or they might be someone that you've never worked with before, to discuss issues that require clarification or resolution. So you issue your RFIs, but at the same time, contact well, if you're allowed to. Sometimes you're not even allowed to speak to the consultant because the builder won't let you. But if the builder is your client, ask the builder if you can talk to the designer about these issues and get them resolved as quickly as you can. And I have found that designers, consultants are usually quite happy to sit down with you and tell you about the design and why they've done certain things. I mean, we didn't design it, so we don't understand why things were done necessarily. There might be good reasons for why they've done things that you don't understand. And this is a good way to get to know the designers and build the relationships, which are really important. You don't want to be fighting people. You want to become friendly with them and able to resolve issues. Okay, you want to get along with them, and you can help each other. You might have some ideas, and you can call the consultant and say, look, what do you think if we do this? And they might be happy about it, they might not, but have that open conversation. Identify any potential value engineering opportunities and discuss with your manager and project manager regarding which options to pursue. Again, you need to talk to the consultant about this as well to see whether they're happy to accept any of these value engineering opportunities. But the idea is to add value to the project. Does it make the project go quicker? Is it a better quality? You know, they might not be aware of the product that you're offering. Again, if there's any long lead time items, prioritise these and seek urgent approval. So then we go through the same process as we go through, marking up drawings to pass on to drafting, review details of all the tendered equipment. So in this case, the suppliers have tendered the equipment based on the designer's documents, and we get copies of their quotes with the data. We need to look at that and make sure it complies with the requirements. And then we know and resolve any non-compliances. They might say, well, look, we can supply this equipment, but it doesn't comply with A, B, C. That may be okay, it may be not. We might have to come up with another plan. Prepare preliminary schedules of all the equipment, carry out the fan static calculations again, control valve schedules again, carry out pump head calculations, acoustic issues, same things that we had before. When the equipment is approved, update the schedule for construction and issue to the, in this case, project manager, drafting, site commissioning, and that's done progressively. And again, I've mentioned, so a bit repetitive, but I've mentioned again, collect whatever data you can for the O&M manuals, and that'll save you time later. So it's, as I said before, always have your binoculars on. What do we have to do down the track? Or you might, if you've got a team of other engineers assisting you, you might allocate one of your team to just concentrate on collecting the O&M data and filing that in the right spot, so that when the time comes to produce the O&M manuals, you've got everything you need. You don't have to spend another month putting it together because, excuse me, as I've said before, with the O&M manuals, you can't finish that until the project is finished. You've got to put in all the commissioning data, all the updated as-built drawings and so on. So you can't actually put that together until the project is finished. However, it becomes the most important document in the project because quite often the builder won't pay your final account until he gets the approved O&M manual. So you don't want to be scrambling around trying to put that together at the end, and the project manager will be jumping on your back saying, come on, we've got to get this done. So whatever you can do up front is going to help you at the end. Yeah, I'll just go right down the bottom for a second. I've said here, if a mistake is made, be honest and resolve it as quickly as possible. Now, I say that because sometimes you make mistakes and you mightn't realise it initially, but as you're working along, you think, oh, we've done something wrong. You know, maybe you've made an error in the peak load calcs or the ventilation calcs or something, and you discover it. There's no point in ignoring it or not telling anyone, because it's going to be a problem. If there's a mistake there, it's going to come back and bite us at some point. So the best thing to do is be honest about it, talk to your manager, tell them what's happened, and you'll find that they'll say, right, how can we fix it? Let's get it resolved and move on. So don't be afraid to do that. And again, it comes back to teamwork. We're working as a team. We support each other. We don't lay blame. We don't point fingers. We say, righto, how do we resolve it? And let's get it fixed. I put in a few inspirational quotes because I used to find some of these things quite handy. You know, I had some colleagues and we used to share this sort of information to give us a bit of encouragement to keep at it, because sometimes it gets pretty hard. You know, if you've got a lot of work on your plate, and I'm sure, you know, you've all felt this, you've got a lot of conflicting priorities that you have to resolve. Those are famous people. Failure is not faith. It's the courage to continue that counts. Don't give up, keep going, and seek support. The journey of 1,000 miles begins with a single step. So start at number one and keep working until you get to the end. Now, this is a good one. By failing to prepare, you are preparing to fail. So remember the 7 Ps that I said at the start there. Good preparation is the best you can do. Things will change and they'll get difficult, but if you've got a good plan, it's half the battle to get to the end. By endurance we conquer. This is Ernest Shackleton, the famous Antarctic explorer. I've been reading books on the Antarctica expeditions recently, and they're fascinating. It's such a tough thing to do, and when if you think it's cold, it's not. So you get in winter, people complaining about how cold it is. It's not really, because down there it's -30 to -50, and they're outside doing things every day. And Nelson Mandela, it's always impossible until it's done. So just, use those inspirational quotes to think it seems impossible, but it's got to be done. So you have to find a way. So with that, so next Tuesday, we'll continue on and we'll talk about the construction phase and how the engineers, what the engineers need to do during the construction phase. And that takes us right to the end of the project. So any questions? It's nearly 11 o'clock, so we've made good time. No questions? Okay, well, we'll leave it there, and I'll send out the notes on Thursday for next week's meeting, and look forward to seeing you then. And Choc, can you say that, please?